Welcome to Mrs. Z's Chemistry. In this video, we will talk about ionic compounds. In normal or ordinary chemical reactions, an atom cannot gain or lose protons or neutrons, which means the nucleus of the atom remains unchanged. This also means that the identity of the atom cannot change through ordinary normal chemical reactions. Only electrons can be added or lost from atoms by transferring to and from other atoms or shared between atoms. There are two different types of bonds that we're going to learn about. Today we're going to learn about ionic bonds, and then later we'll learn about covalent bonds. Ionic bonds are formed when electrons are transferred from one atom to another. The ionic bonds are formed between a metal and a nonmetal. The covalent bonds are formed between two nonmetals, and we'll learn more about them later. Atoms can either gain or lose electrons, forming electrically charged particles called ions. We often call these electrostatic forces. We can use the periodic table to predict whether an atom will form an anion, a negatively charged particle, or a cation, a positively charged particle. Atoms want to have the same number of electrons as the nearest noble gas on the periodic table. Metals readily use electrons to become cations, and nonmetals readily gain electrons to become anions. Because atoms want to have the same number of electrons as the nearest noble gas on the periodic table, you can think of the noble gases as the celebrities of the periodic table. Everyone else looks up to them and wants to be like them. Remember that your noble gases are the elements in the far right-hand column. So let's look at this blank periodic table. First, let's consider lithium, which is number 3. Lithium has 3 protons and 3 electrons when it is neutral. The nearest noble gas to lithium is helium, which is number 2 up here. Lithium would need to lose 1 electron in order to have the same number of electrons as helium. Lithium is not changing into helium. Lithium is still lithium because it still has 3 protons, but it is just losing 1 electron, and therefore it now has a positive 1 charge. Think of it this way. Here are the 3 protons of lithium. When it is neutral, it also has 3 electrons. You can see that each positive is canceling out with a negative. But when it loses 1 electron, it now has 1 extra positive proton that is not getting to cancel out with a negative electron. Therefore, lithium, after it loses 1 electron, has a positive 1 charge. Now let's look at beryllium, which has 4 protons and 4 electrons. Beryllium is Be on the periodic table. When it is neutral, it has 4 protons, 4 electrons. Therefore, it would like to lose 2 electrons in order to have the same number of electrons as helium. Beryllium then would have a +2 charge when it forms an ion. Let's move over to the other side of the periodic table here. Boron, which is just a capital B, has 5 protons, 5 electrons. Therefore, it would like to lose 3 electrons in order to have the same number of electrons as helium. Boron makes a 3+ charge when it forms an ion. Now we're going to look at fluorine. We'll move to elements 6, 7, and 8 later. Fluorine has 9 protons and 9 electrons when it is neutral. The nearest noble gas to fluorine is neon, right here, Ne. Neon has 10 protons and 10 electrons when it is neutral. Therefore, fluorine would like to gain 1 electron in order to have the same number of electrons as neon. Fluorine makes a -1 charge. Oxygen has 8 protons and 8 electrons when it is neutral. It would like to gain 2 electrons in order to have 10 electrons like neon. Therefore, oxygen makes a 2- charge. Nitrogen has 7 protons, 7 electrons. When it is neutral, it would like to gain 3 electrons, forming a -3 charge in order to have the same number of electrons as neon. You can see that carbon here, number 6, is right in the middle between helium and neon. It could lose 4 electrons and have the same number of electrons as helium, or it could gain 4 electrons and have the same number of electrons as neon. So we say that carbon can make a +4 -4 charge. Of course, carbon could not do this simultaneously because then it would just have the same number of electrons as a neutral carbon atom. But in some compounds, carbon will lose 4 electrons, and in other compounds, carbon will gain 4 electrons. Now let's move back to the left-hand side of the periodic table and look at sodium. Sodium has 11 protons and 11 electrons when it is neutral. Neon is its nearest noble gas. Therefore, sodium would like to lose 1 electron, forming a +1 charge. Potassium, number 19, has 19 protons and 19 electrons when it is neutral. Its nearest noble gas is argon, which has 18 protons and 18 electrons. Potassium then would like to lose 1 electron and form a +1 charge in order to have the same number of electrons as argon. I'm sure you're seeing the pattern here. All of the elements in the first column form a +1 charge, including hydrogen actually, because they all have 1 more electron than the nearest noble gas right before them on the periodic table. On your periodic table, you can label the first column as a +1 next to the alkali metal label. The next column over is the +2 column. Beryllium makes a 2+ charge. Magnesium here has 12 protons, 12 electrons when neutral. Its nearest noble gas is neon, number 10, which has 10 electrons. So magnesium would like to lose 2 electrons and form a 2+ charge, so it has the same number of electrons as neon. Everything in this second column does the same thing. They would all like to lose 2 electrons in order to have the same number of electrons as the nearest noble gas. Let's fill in our staircase right here, because this pattern only applies to elements above the staircase. The fluorine column here, which is number 9, is the -1 column. Each of these elements need to gain just 1 electron in order to have the same number of electrons as the nearest noble gas, right after them on the periodic table. Oxygen, sulfur, selenium, and tellurium, they all form -2 charges. Remember that this only applies to the elements above the staircase. Nitrogen, phosphorus, and arsenic form -3 charges, as they each need to gain 3 electrons to have the same number of electrons as the nearest noble gas. And then carbon and silicon each make either +4 or -4, depending on what element it's making a compound with. Aluminum here, which is number 13, it is the only exception for the staircase, above the staircase rule. Even though it's below the staircase, it does follow the same pattern, and it makes a +3 charge. Everything else, I'm going to circle these in a different color, but all the other elements here, right underneath the staircase, these are the transition metals, and they do not make charges or cations based on a pattern. So we can't predict just by looking at the periodic table what charge it makes. All of these elements that I have circled in blue, they can sometimes make lots of different charges, either +1, +2, +3. They will always be a positive charge because they're metals and they will always lose electrons, but you're going to have more information to figure out what charge it's making in the given example right in front of you. So let's look at a sample problem. An ion found in some compounds used as antiperspirants contains 13 protons and 10 electrons. What is its symbol? Well, the 13 protons tells us what element it is. Looking at the periodic table, that is aluminum, Al. The fact that it has 10 electrons tells us that it must have a 3+ charge. There are 3 more positive protons than there are negative electrons. Give the symbol a name for the ion with 34 protons and 36 electrons. 34 protons on the periodic table tells us that the element is selenium, Se. And because it has 2 more electrons than it does protons, we know that this has a -2 charge. And there are your answers. Let's do 2 more samples. Magnesium and nitrogen react to form an ionic compound. Predict which forms an anion, which forms a cation, and the charges of each ion. Write the symbol for each ion and name them. Magnesium has Mg as its symbol, and nitrogen a capital N. The magnesium is in the 2+ column on the periodic table, therefore it makes a 2+ charge, and it is the cation. The nitrogen is in the 3- column, and it is the anion. Aluminum and carbon react to form an ionic compound. Predict which forms an anion, which forms the cation, and the charges of each ion. Write the symbol for each ion and name them. Aluminum makes a 3+ charge. Therefore, carbon must be the 4- in this case. Carbon can make either +4 or -4 because in this example it is forming a compound with a positive element, aluminum. Carbon is making a -4 charge in this example. Let's look at these names. When we have a cation, a positively charged element, the name stays the same element name, so magnesium, and you just add the word ion. So magnesium ion is the way you name this Mg2+. The anions, however, have the ending of the element changed to "ide." So instead of saying nitrogen ion, we say nitride ion. Of course, everyone would know what you're talking about if you said nitrogen ion, but the proper way to say it is nitride ion. Al3+ is the cation, so we just name it as aluminum ion. Carbon is the anion, so we label it carbide ion. Cations are attracted to anions. The ions must form compounds to have a neutral charge overall. So in this example, a sodium ion is transferring an electron to the chlorine, and it's forming NaCl, which is a neutral compound overall. Here's a visualization here. We've got 11 protons in the very center, and then the 11 electrons are in the electron cloud outside of the nucleus. When the sodium atom transfers an electron to the chlorine atom, the sodium atom becomes a little bit smaller because it now has much less electrons, or at least one less electron. And the chlorine actually becomes a little bit larger because it now has more electrons than it used to. Then the positive and negative particles are in alternating fashion in sodium chloride, or NaCl. And overall, it's going to have a neutral charge. Negative, positive, negative, positive, and then the row above it, positive, negative, positive, negative, so that every negative particle is surrounded by 6 positive particles, and every positive particle is surrounded by 6 negative particles. Let's make some more compounds. What charge does calcium make, and what charge does chlorine make? Pause to see if you can figure this out. Calcium makes a 2+ charge, and chlorine a -1 charge. What is the ratio between calcium and chlorine when they make an ionic compound? Pause to see if you can figure this out. In order to make a neutral compound, we're going to need 1 calcium and 2 chlorines. And that's because the chlorine only makes a -1 charge, so we need 2 of them to cancel out the +2 charge from the calcium. The ionic compound is written like this, CaCl2, where the 2 applies just to the chlorine. The positive cation is always written first in ionic compounds. Do the next problem by yourself. Potassium makes a +1, oxygen makes a -2. The ratio is 2 to 1, and the compound is K2O. Again, the positive cation is always written first. And here are all the answers. A compound that contains ions and is held together by ionic bonds is called an ionic compound. When a metal is combined with one or more nonmetals, the compound is ionic. And here are a few examples. The metal is a potassium, nonmetal is the fluorine ion. Together, because of the +1 and -1 charge, we just need a 1-to-1 ratio of the two. Kf is the ionic compound. Every ionic compound must have a total number of positive charges that equal the total number of negative charges, so that ionic compounds are neutral overall. Let's try these 2 examples. The gemstone sapphire is mostly a compound of aluminum and oxygen that contains aluminum cations, Al3+, and oxygen anions, O2-. What is the formula of this compound? Pause to see if you can work this out. The answer for this is Al2O3. And let's look at this a little closer. So if we have one of each, Al3+ and O2-, you can see that the charges would not cancel out. We don't have enough negative charges. So let's add another negative oxygen. Well, now we have too many negative charges and not enough positive charges. So let's add another positive charge. And now we have too many positive charges, so let's add another negative charge. And now you can see that the total from the aluminums is a 6 plus, and the total from the oxygens is a 6 minus, overall giving us a neutral compound. That is why the chemical formula is Al2O3. Predict the formula for the ionic compound formed between the sodium cation, Na+, and the sulfide anion, S2-. The answer is Na2S.